Welcome to the finals revision. The first question we will have on finals is about vectors and finding an angle between those vectors. Okay, let's do it. So we have two vectors, AB and AC. You see, I already did some remarks here. So AB and AC. AB is minus 2, 6, minus 3. AC is minus 2, minus 3, 6. Let's do it. So first we have to determine the lengths of this vector. So A, we have to determine how long is AB and how long is AC. So a magnitude of vectors, again, I have a formula here. So if you have vector with components L, M, and N, then the magnitude of this vector is square root from L squared plus M squared plus N squared, like this. So for AB, the components are minus 2, 6, and minus 3. Then the magnitude of AB equals to square root from minus 2 squared. Please don't forget to put the brackets next to the negative numbers, okay? Don't forget about this. Minus 2 squared plus 6 squared plus minus 3 squared, like this. Then it's equal to, it's going to be like 4 plus 36 and plus 9, which is like square root of 49. Which is like 7, yeah, which is equal to 7. Next we do magnitude of AC, which is actually the same thing. You will see why shortly. So AC is minus 2, minus 3, and 6. So minus 2 squared plus minus 3 squared plus 6 squared equals to 4 plus 9 plus 36, again equals to square root of 49, again equals to 7. That's it for part A of this question. Let's go to part B. So in part B, find the scalar product AB dot AC. So here we have the formula for scalar product. There's actually two formulas, right? So P dot Q. In our case, it's AB dot AC. So we can draw it like this. AB and AC. They are two vectors, so B and AC. We don't know the angle between them, right? So we cannot use this formula. We cannot use this formula because it requires us to know the angle. So we have to use the second formula, LU plus MV plus NW. You see, and here I already marked. So this is our L, this is our M, sorry, and this is U. This is V and this is W finally, yeah? Like this. Let's get it done, ladies and gentlemen. So we have to use this formula again, right? So AB dot AC vectors, right, equals LU. So minus 2 times minus 2. So minus 2 times minus 2 plus MV. So that's 6 and minus 3, right? 6 times minus 3 plus NW. So NW, right? So minus 3 times 6, yeah? Which is 4 minus 18 minus 18, which is equal to negative 32. And for the last one, we can, so we have to find angle between vectors, right? Maybe you remember the formula comes from here. We redo this formula, so we have the formula like this: PQ, right, cosine theta is equal to LU plus MV plus NW, right? But if we want to make cosine theta the subject, right, so cosine theta would be equal to LU plus MV plus NW divided by magnitude of P times magnitude of Q, like this, yeah? So we can say that cosine of the angle that we are actually looking for, and this angle is BAC, right? BAC is the name of this angle, is this one, yeah? You want to find this angle between vectors AB and vectors AC, right? AB and AC. So we have to do what? What do we have to do? We have to cosine of BAC is equal to LU plus MV plus NW. But we just did that, right? We just found it. So this is our LU, MV, and W, right? We just did it in B. So we already know this. It's actually equal to 32, negative 32, sorry. So we write negative 32 on top, and on bottom we write, what is it? P. So in our case, P is AB, right? And we already found magnitude of AB is equal to 7, yeah? So we write 7 times, and Q, in our case, Q is second vector. So again, I can just like write it here actually, A. So this is A, B, C, right? So actually in our case it's like this. Yeah, just give me a second. Actually it's like this actually. Let's like make it normal, yeah? Actually it is a so Q is actually the second one, so Q is AC, so this is AC and this is AB, like this. Okay, back to the topic. So AB is 7 and AC, the magnitude is also 7, right? Magnitude of AC is 7. So it's 7 times 7 equals minus 32 over 49. Ladies and gentlemen, look at this. And then BAC, the angle BAC would be equal to cosine inverse from this number, so minus 32 over 49. Now we take our calculators. One thing about calculators here is that, again, look at the question. The question tells you to find angle in degrees, right? So be careful about these degrees. And in this exam, you will have to use both degree mode and radian mode. So make sure you know how to switch between them. Make sure you know this. So in this case, it's degree mode. You see, it's degree mode. I can switch to radian mode. In your calculator, maybe it's a bit different. You have to go to mode and like do some stuff, but my calculator is not like that. Anyway, cosine inverse from negative 32 over 49 is equal to 130.77 to 1 decimal place, right? 1 decimal place, always read the question. So it's actually 130.8 degrees. Okay, that's it for the first question. Please take a look carefully. We go to the next one. Find unit vectors in the same directions as, and then we have two different vectors. So it's actually quite easy to find unit vector in the same direction. So the formula is, I will write the formula for you. So unit vector in direction of P. Let's say we have this like a default vector P, right? Of vector P is equal to, and let's say P is equal to, again, LMN, yeah? So unit vector in direction of P is equal to P as a vector divided by magnitude of P. So every part of vector P, like this, every part LMN has to be divided by magnitude of P, like this. This is our formula. So in case of the first one, let's number them. So this is A, and this is our B. Yeah. So let's do A. For A, the magnitude of this vector, let's give it a name. Okay, let's just call it A. Why not? So this is vector A, and this is vector B. So magnitude of vector A is equal to square root from 1 squared plus. Please don't forget about brackets before negative numbers and after 2, plus negative 2 squared plus 2 squared, yeah, equals to square root from 9 equals to 3, yeah. So unit vector in in direction of A equals to components of A, right? So 1 minus 2, 2 divided by 3. So every component of A has to be divided by 3. So it's 1 over 3, minus 2 over 3, and finally we have 2 over 3, like this, ladies and gentlemen. This is the question. Second one is like almost the same thing, but now we write it differently. But anyway, so B, but this is, by the way, absolute value, the magnitude. So magnitude of B equals to square root from 2 squared plus minus 1 squared plus 2 squared. Actually it's the same thing, basically almost the same, equals to again square root of 9 equals to 3, right? Unit vector in direction of B, and now let's use the form that they use here, equals to 2I plus j minus 2, plus 2k minus j, right? 2I minus j plus 2k, and all of this divided by 3, right? So that's going to be equal to 2 over 3I minus like a j over 3, basically. Yeah, j over 3, and plus 2 over 3k. Yeah, we can write it like that. Okay, that's it for the unit vectors. So again, the formula is quite simple. Please try to remember it, or just remember the concept of this formula. Okay, this is another question. Next one is going to be, again, okay, as some students pointed out, I did some mistakes in this question, so I will have to redo it again. This is 2j. This is 2j here. This is 2j, and so OC is, OC is 2j, OA is 4i, and OD is 3k, right? And now we have to find AG. So let's do everything again just in this question, right? AG goes like this. AG goes like this. Yeah. Let's find it. So AG, again, we can say that AG is equal to, AG is equal to AO plus OG, right? Which is equal to, so AO is minus 4i, like this. And OG is OD plus DG, which is 3k plus 2i, right? DG is the same as OC, so it's 2j. This is 2j. DG equals to 2j. Sorry about that. A lot of mistakes today for me. Hey. So this is 3k plus 2j. So it's, or we actually should say 2j plus 3k, right? We should say in this case. This should be more correct, because we have to keep them in alphabetic order. So it's 2j plus 3k, and then it's equal minus 4i plus 2j plus 3k, right? Then size of AG, the magnitude of AG is equal to square root from minus 4 squared plus 2 squared plus 3 squared, right, would be equal to square root from 16 plus 4 plus 9, square root from 29, still the same, yeah? And then the angle, so the angle is probably going to change. The angle between HE and OB, so again, HE is minus 4 2, 3, like this. Yeah. And what else? What else? OB. OB. Can we find OB? Yes, we can find OB quite easily. OB equals to OA plus AB, right? AB is equal to 2J as well, so this is 2J. So OB is going to be 4I plus 2J, like this. This is our OB, right? So OB equals to 4I, so it's 4. 2J is, this is 0. So 420, I'm sorry, 420, AG and OB. And then the angle would be cosine from theta is equal to LU plus MV plus NW divided by, what's it gonna be, like P times Q. So in this case it's AG times OB, right? So then the angle is going to be equal to cosine inverse from all this thing, and let's find it. So it's going to be LU, right? So we have our AG and we have our OB together. So LU is minus 4 times 4, so we go like this. So it's again it's a cosine inverse from L, so LU, so LU minus 4 times 4, so we go minus 4 times 4 is minus 16, 2 times 2 is 4, so minus 16 plus 4, and then 3 times 0 is 0, so minus 16 plus 4 divided by AG. So AG is what is it gonna be? It's gonna be square root from 29, and OB is like square root from 4 squared plus 2 squared, right? Like this. Then we close the brackets finally, and we get our answer. So actually it's this is in radians. I have to change to degrees. So actually it's 119 degrees, almost 120. So 119.9 degrees. 119.9 degrees. Okay, this is 100% right answer. I hope so. Next one is about, okay, now we get to the radians. Length of a circular arc with radius r. So this is formulas. I took some formulas here for you. Find the perimeter of the segment cut off by a chord of length 14 centimeters from a circle radius 25 centimeters. Okay, let's draw a circle. Yeah, why not? Perimeter of a segment cut off by chord. So the chord, there's a chord here, right? From a circle radius 25 centimeters. So let's say this is the center of the circle, probably around here, and the radius of the circle. So let's draw it like this. Yeah, this is going to be a radius, and this is going to be a radius. This is 25. Oh my god, it doesn't look like that, right? But anyway, and this is 25, and this is 14. This is our chord. It's 14 centimeters. It looks way bigger than that, but that's okay. Anyways, so how do we find perimeter of the segment? Again, the segment cut off by a chord. Yeah, so this is the segment, this part plus this part, right? This would give us a perimeter. So perimeter of the segment equals 14 plus whatever is the length of arc here. And again, the formula for length of arc is length of arc equals to radius in just radius, right, times theta, where theta is the angle in radians. So again, this formula is for radians. So how can we find this angle? Is it possible Turns out yes, and it's quite simple actually. So the thing we can do, we don't even have to use the cosine theorem. We can just drop the height here. It's going to cut it in half, this chord. So this is going to be 7 here and 7 here. Then we have, look at this, we have this triangle, 25, 7, and also this degree is cut in half. So we can just find this degree. Is it possible to find it? Yes, it is, right? This is our hypotenuse, and this is our opposite, right? So sine of some angle, and let's draw it like this. Let's say this is angle alpha, right? Let's say this is angle alpha is equal to opposite over hypotenuse, right? So it's 7 over 25. Then this angle is equal to sine inverse from 7 over 25, right, equals 2. Again, you take all out your calculator. Sine inverse from 7 over 25. Yeah. Then you get this 16.26. Oh, but we have to use radians, right? You see, before we use degrees, now we use radians. Pay attention to this, okay? The degrees and radians. Pay attention what your calculator is showing you. So 0.28 radians. 0.28 radians. 0.28 radians. Right, so this is angle, but don't forget that this is only half the angle. We just found half of the angle. Another half is also 0.28, right, and then together it's going to be, together this big angle is like 0.56, right? So this arc would be equal to length of this arc. This is our S in this case, yeah? Length of this arc equals to radius times this angle, right? So radius is 25 times 0.56, which would be equal to 25 times 0.56 equals to 14. So perimeter, how interesting, equals to 14 plus 14. Right, so 14 plus 14 would be equal to 28 centimeters. Again, this 14, let's mark them with different colors. This 14, it comes from, this 14 comes from the length of this thing, and another 14, it comes from the length of arc, right? This is where it comes from. Okay. That's it for this question. Quite an easy question, I think. Next one, what is it about? Of course, the equation. There's going to be an equation, and it's going to be, you will have to use identities as well. So you see here it's like tan, and there is cosine. So 2 in 1, both tan and cosine. So we have to convert them. We can use identity. Tan equals to sine over cosine, right? Then tan squared equals to sine squared over cosine squared, right? Which is equal to 2 cosine squared of theta. Yeah, we can take this cosine here. We will get sine squared of theta equals to 2 cosine to the power 4 of theta. Yes, sine squared can be written as, this can be written as 1 minus cosine squared of theta, because identity, right? So 1 minus cosine squared of theta equals 2 cosine power 4 of theta. Let's take it all to one side. So 2 cosine power 4 of theta plus 2 cosine squared of theta minus 1 equals to 0. Let's say we replace it. So let's say that cosine from power 4 equals to x squared, then cosine power 2 equals to x, right? Then what do we get? What do we get from this? So 2x squared plus x minus 1 equals to 0. Okay, I'm gonna solve this quickly because I believe you guys know how to solve quadratic equations. But again, maybe on your calculator there is also such a thing as quadratic equation solver. Anyway, there is a formula for solving quadratic equations. Yeah, so it's -1, x equals to -1, and then x equals to 0.5. X equals to 0.5. This is actually quite an easy question, and it has to be between minus pi and pi, right? So cosine squared of theta equals to -1, and cosine squared of theta equals to 0.5. Again, cosine squared, it comes from here, right? Cosine squared equals x, so that's where we get to it. Yeah, and then we go here and here. Yeah, like this, because there's two x's. This one is actually dead end, so here we have dead end. So cosine of theta equals to square root of -1. There is no such thing, at least not right now. Very soon, if you still study this course, you will know what is square root of -1, but right now, no, we cannot do that. And then cosine of theta equals to a root from 0.5, which is it's like 0.7. Let me make it approximate for you, okay? So it's like 0.7, and that, like, from this point you have to find cosine inverse from 0.7. This is the first step, right? So you find cosine inverse from 0.7 equals to, and again here you have to use the radians. Oh my god, why is it, I need this. Yeah, you need to use radians here, because why is it not working? Yeah, you have to use radians. Why? Because you see here they tell you it's from minus pi to pi, so this is obviously radians. So 0.79 is like 0.8, let's say, so it's equal to approximately to 0.8 radians. Again, from minus pi to pi, so it's from minus 3.14 to 3.14, we could say, right, approximately. Then we can find the rest of them. Yes, so second option is cosine of 0.8 equals to cosine of negative 0.8. So that's the second one. That's the second root. And then we can do plus minus 2 pi, but that's going to go too far, right? This is not going to bring us anywhere. So like if we go from here, if we go plus 2 pi, it's too much, right? It's too much. If we go minus 2 pi, it's too little, right? And the same goes for here. So our answers are 0.8 and negative 0.8. That's it for the trigonometric equations. Again, if you have some questions about trigonometric equations, then please, there is a good page which you can use for your review in the book. Let me find it in just a second. Yes, this is a page, you see, 18.5. This is where they tell you all the steps for solving all three types of trigonometric equations, with sine, with cosine, and with tan. It's page 273 in the book, which you can find in the Google Classroom. Okay, and the last question, finally we get to the polynomials, and I can tell you the question in the exam is going to be quite similar to this question. Of course, not the same, but quite similar still. So when this thing is divided by x minus 2, the remainder is 25. When divided by x plus 1, the remainder is minus 5. Find the values of a and b. So this is our p from x, right? Because we're talking about, we have to use remainder theorem for this. When a polynomial p from x, so p from x, is 2x cubed minus x squared plus ax plus b, right? So when p from x is divided by x minus 2, the remainder is 25, right? It means that 25 is our p from t. So p from, and t comes from here, so x minus, so this is our, you see, this is our x minus t. So in this case the t is equal to 2. So p from 25 is, p from 2 is equal to 25. Again, 2 comes from here. It has to be negative. I know this is a little bit counterintuitive. So, and then another one is when p from x is divided by x plus 1, the remainder is it still filming? Yeah, it's still filming. Just wanted to be sure. The remainder is minus 5. So this means that p from, and this time you see it's plus 1, so it should be minus 1 here. So p from minus 1 is equal to minus 5. So we have two things, right? This is the key part. P from 2 equals 25. P from minus 1 equals 5. So P from 2 equals to 25. And P from minus 1 equals to minus 5, right? Let's find, so P from 2. So what we have to do is we have to take 2 and we have to replace x here with 2, like this, yeah? So P from 2 is equal to 2 times 2 cubed minus 2 squared plus a times 2 plus b, and that is equal to 25, right? And then if it's minus 1, so it's 2 times minus 1 cubed minus minus 1 squared plus a times minus 1 plus b is equal to minus 5, like this. And now this becomes a system of equations. Let's simplify it first. So 2 times 2 cubed, so it's like 2 times 8, which is 16. So we have 16 minus 4 plus 2a plus b equals to 25, right? And then 2 times minus 1 cubed, so it's minus 2 minus 1 minus a plus b equals to minus 5. You see, this is just a system of equations, yeah? So we take the number, so 16 minus 4, again, this is what we have. Let's take this number, so together it's 12. Let's take it to the other side. Let's take it here. It's going to be minus 12. This together, this is minus 3, right? Let's take it to the other side. It's going to be plus 3, yeah? So we get 2a plus b equals to 25 minus 12. And then minus a plus b equals to minus 5 plus 3, yeah? Like this. So 2a plus b equals to 13. Minus a plus b equals to minus 2, yeah? Okay, now we can find this. We can subtract them from each other. We would get 2a, if we get 3a equals to 3a plus 0 equals to 15. So a equals to 5, and then it means that, so minus a, so minus 5 plus b equals to minus 2, it means that b is equal to b equals to minus 2 plus 5, right? We take 5 here, so b equals to 3, right? So b equals to 3, a equals to 5, b equals to 3. Okay, take a look at this whole question one more time. This is going to be published in your notes as well in Google Drive. You can see all these notes. This is your exam revision. I just show you what the questions in the exam are going to be like. And that's it for now. Good luck on your exam.